Do you feel the vibes?
Hello everyone, how are you today? Let's complete the explanation of algebra for the third year of middle school with Mr. Ahmed Samir. Today's lesson is beautiful, fun and important. It is called functions. Let's learn what is the meaning of functions and its applications. In the opposite figure, there are three modules represent the relation between x and y. Let's write the relation for each one. R1 equals 3, 1, 5 and 3, 6 and 7. R2 0, 5, 2, 1, 2, 3, 4, 5 and 6, 9. R3 2, 2, 1, 0, 5, 2, 4 and 3. We have a question now. Which of these relations satisfies the following condition? We have a condition now. Each element of x is connected to only one element of y. Again, each element in x, in the set x, is connected to only one element of y. Which one? In R1 we notice that the number 2 doesn't connect to any element in y. In R2 the element 2 is connected to two elements in y, not one only. But R3 each element of x is connected to only one element of y. 2 with 2, 1 to 0, 5 to 2 and 4 to 3. So we will find that the relation 3 satisfies this condition. So we can say that a relation from x to y, it's said to be function f. Each of the elements of x appears only once as a first projection in one of the ordered pairs of the relation R. So again, if each of the elements of x, of the set x, appears only once as a first projection in each one of the ordered pairs of the relation, that is called function. And if each element in x is connected to one element of y, that is called function. Let's see an example. If x 3, 5 and 7 and R is a relation on x, then the relation which represents a function is, let's see, our condition is each element in x should appear only once as a first projection. So we can see 3, 5, 7 in the first projection once. Let's see our choices. Letter A, 3, 5 and 3 in the first projection, so 3 repeated 2 times. B, 3, 5, whereas 7 in the first projection not exist. C, R equals 3, 5 and 7, and D, 3 repeated 3 times. So the correct answer is C, 3, 5 and 7. All elements of x appears only once as a first projection. Another example. If R is a function from x to y, where x 258, y 35, and r equals 2, 5 and x, the first projection must be from the set X. We saw 2, 5, so the third ordered pair will be 8 and anything in Y, but the important the elements of X. So 2, 5, the remaining is 8. Another example, if X 0, 1, 2, 3, Y negative 3, negative 2, negative 1 and 0, and R is a relation from X to Y where A relation B means A is the additive inverse of B, the opposite sign, the same integer but by opposite sign. For all A belongs to X and B belongs to Y, write R and represent it by an arrow diagram. The last question, it R is a function and Y. Let's see. First of all, let's write the relation between X and Y. Our condition is A is additive inverse of B, so we can see 0 with 0. 0 is the additive inverse for itself, and 1 and negative 1, A or X, the element 1 is additive inverse for negative 1, 2 with negative 2, 3 and negative 3, like the relation R here. And let's draw the arrow diagram. 0 with 0, 1 negative 1, 2 negative 2 and 3 with negative 3. Now it R is a function. Let's see. Our condition, each element in X should appear only once as a first projection. Elements of X 0, 1, 2, 3 in R 0, 1, 2, 3. All the elements appears only once as a first projection. So R is a function. Another example, if X 2, 5, 8, Y 10, 16, 24 and 30, and R is a relation from X to Y for all A belongs to X and B belongs to Y, where A is a factor of B. What is the meaning of A is a factor of B? Now let's see. 2 and 10, 16, 24, 30. 10 consists of 2 factors, 2 times 5. If we analyze 10, we'll see that 10 consists of 2 multiplicated numbers, 2 times 5. So 2 is a factor for 10, and 16 2 times 8, so 2 is a factor of 16. 24 2 times 12, 2 is a factor of 24, and 30 2 times 15, so 2 is a factor of 30. The element 5, 10 2 times 5, so 5 is a factor of 10. 16 and 24, 5 is not a factor for them, but 30, 5 times 6, so 5 is a factor for 30. 8 with 10, not a factor. 8 with 16, 8 times 2, so 8 is a factor for 16. 8 is a factor for 24 because 8 times 3 equals 24. Finally, 8 is not a factor for 30. So let's write R. R equals 2 and 10, 2, 16, 2, 24, 2 and 30. The second element, 5, 10, 5, 30, 8, 16, 8, 24. We can notice that 2 is repeated 4 times, 5 repeated 2 times and 8 2 times as a first projection. So we can represent it by an arrow diagram like this: 230, 224, 216, 210, 510, 530, 816 and 824. You can ask yourself, is R a function? You can apply our condition. Each of the elements of X appears only once as a first projection? No. So it's not a function. Another point in our lesson, let's express the function by symbolic sentence. We can denote the function by any letter as F, G, M, so on, but the famous is F from the word function, the first letter. So we can express the function F from X to Y by the following form, like this: F 2 dots X ray Y means F from X to Y, 2 dots means from, array means 2, F from X to Y, function between X and Y, relation between X and Y. We have another form, but important form: F of X equals Y. That means function from X to Y. F of X equals Y, a relation between X and Y. The image of X is Y. That is important. The image of X is Y. The second projection of X is Y. We can express it by ordered pair: first projection X and second projection Y. So the ordered pair 3 and 4 means F of 3 equals 4. The image of 3 is 4. If we substitute in the function by 3, the result will be 4. Now we can form an ordered pair from the function, because the function express a relation between two numbers, two elements, and the opposite. F of negative 2 is 5, forms the ordered pair negative 2 and 5. If we substitute in any function by negative 2, will be 5. Let's see an example. F X, F function F equals 5x minus 7. That is called a function. F of X equals 5x minus 7 is a sentence, symbolic sentence. Then F of 3. What is the meaning of F of 3? We will substitute X by 3. We will replace X by 3 and substitute here. We will replace here X by 3. So Fx means F times X. So will be F times 3. We substituted by 3. F times 3 minus 7. 5 times 3, 15. 15 minus 7 equals 8. Now we can form an ordered pair from them. The first projection is 3 and the second projection is 8. Another example. F of X equals 6x. Now we want F of 2 plus F of negative 2. We will substitute once by 2 and another time by -2, and we will add them. If f2, we will replace x by 2. 2 times 6, 12. 6 times 2. And let's replace x by -2. 6 times -2 equals -12. 12 plus -12 equals 0. If the point A and 3 lies on the straight line which represents the function f from R to R, where f of x, that is the important relation, f of x, the function x, equals x minus 5, then A equals what? We said that if we have an ordered pair, the first projection is x, and the second projection is the image of x. The image of x is f of x. So f of x equals 3. We can replace f of x by 3 and x by a. So we can form it. We replaced x by a minus 5 and f of x by 3. Now we have an equation. So a will be 8. Then the point 8 and 3. Another example. The linear function f of x equals x plus 7 is represented by a straight line cuts x axis at the point what? If we want the point represents cuts x axis, we will replace f of x by 0. If we want the point that represents the straight line cuts x axis, we will replace f of x by 0, because we will find a point, the second projection with 0, or y axis with 0. F of x express y axis equals 0. So the second projection will be 0, and we can replace f of x by 0. X plus 7 equals 0, so x will be -7. Then the point will be -7 and 0. Another example. The linear function f of x equals 2x minus 1 is represented by a straight line but cuts y axis. At the last example, cuts x axis. In this case, in x cuts x axis, we will put f of x by 0, and we will find x, and we will form the point. If the function cuts y axis, we will put x by 0, and we will find f of x, the image of it. Let's see. If 2x minus 1, we will replace x by 0 equals 2 times 0 minus 1. 2 times 0 equals 0. 0 minus 1 equals -1. So our point is 0 and negative. The last point in our lesson, we have 3 concepts for the function: domain, codomain, and range. Let's recognize what is the meaning of domain, what is the meaning of codomain, and what is the meaning of the range of the function. If we have a function from x to y is represented by the arrow diagram, we have the elements of x. All the elements of x are called the domain. So the elements of x are the domain. of the function f. So the domain 0, 1, 2 and 3. And in the opposite, the elements of the set y here are called the codomain of the function f. So the codomain will be 0, 1, 2, 3, 4, 5 and 6. But we have the image of each element of x. The image of 0, 0, the image of 1, 2, the image of 2, 4 and the image of 3, 6. We have the images of the domain are called the range of the function. So the range here is 0, 2, 4, 6. So the range is subset of the codomain or the set y, and the range is the images of the elements of x. Let's understand more by an example. If x 2, 3 and 4, y 3, 4, 5, 6, 7 and 8, f from x to y, where f of x, the function, the condition f of x equals 9 minus x, finds the images of the elements of x. So we will replace x by the elements of it like this. First of all, f of 2, we will replace x by 2. So 9 minus 2 equals 7. We can form ordered pair 2 and the image is 7. By the same way, f of 3, the second point, 9 minus 3, 6. Then the ordered pair will be 3 and 6. Finally, the third element in x, 4. We will replace x by 4. 9 minus 4 is 5. Now we can write the relation. The relation here 2, 7, 3, 6 and 4, 5 in braces. Secondly, represent it by an arrow diagram like this: x, y, and 2 connect to 7, 3 with 6, 4 with 5. Finally, write each of domain, codomain, and the range of f. The domain here is all the elements of x. So the domain equals 2, 3 and 4. The codomain is all the elements of y, 3, 4, 5, 6, 7 and 8. Finally, the range. The range is the images of the domain 5, 6 and 7, subset of y. So range equals 5, 6 and 7. Now we finished our lesson. I hope you benefited from this session and wait for me next session. Thank you for listening.